Imagine a lone spacecraft built by human hands travelling billions of kilometres into the outer solar system. Ahead of it lies the largest planet we know, a gas giant wrapped in swirling storms and intense radiation. Few machines have dared to get this close to Jupiter, and fewer still have survived. This is Juno, NASA's bold mission to uncover the hidden secrets of Jupiter. Launched in 2011, it arrived at its destination on July 4th, 2016. Its journey is more than just another chapter in space exploration. It is a story of ingenuity, risk and discovery. But what exactly makes Juno so special? How did it travel all that way? And what questions is it trying to answer about Jupiter and even about ourselves? By the end of this video, we'll understand Juno's mission, the challenges it faces, and why this small spacecraft carries such an enormous scientific weight. So, let's begin at the very start of the story. For NASA, Juno was considered a medium-budget mission. The total cost spread across more than a decade of planning and operations was expected to be around $1.1 billion. That is a lot of money, but in the world of space exploration, it places Juno somewhere between the smaller exploratory craft and the larger flagship projects. What makes Juno particularly fascinating is how it generates power. Unlike many deep space probes before it, which relied on nuclear power, radioisotope, thermoelectric generators, Juno runs entirely on solar energy. Now you might wonder, how can solar panels possibly work so far from the sun? At Jupiter's distance, sunlight is only about 4% as strong as it is at Earth. That means the spacecraft needs very large panels, far larger than anything we've sent that far before. In fact, Juno is the most distant solar-powered spacecraft in history. Each of its 3 solar arrays stretches out several meters, giving it a wingspan wider than a basketball court. Thanks to improvements in solar cell efficiency, these massive panels can still collect enough energy to keep the probe alive, even in the dim outer reaches of the solar system. It is a remarkable feat of engineering, proving that sunlight, weak and distant as it may be, can still power exploration far beyond Mars. Juno was launched on August 5th, 2011, atop an Atlas V rocket from Cape Canaveral, Florida. The launch is always one of the riskiest moments of any space mission. After years of preparation, all the hopes of the project depend on a few minutes of fire and controlled chaos. But Juno's launch went smoothly. Less than an hour after liftoff, it was already on a trajectory out of Earth's orbit, headed into deep space. But here's where the story gets interesting. Instead of flying directly to Jupiter, Juno took a rather unusual path. 2 years after leaving Earth, it returned to our planet. Why? Because of a clever trick in orbital mechanics known as a gravity assist. As Juno swung past Earth in October 2013, our planet's gravity pulled on the spacecraft, slingshotting it forward and increasing its speed by more than 14,000 kilometers per hour. This maneuver gave Juno the extra boost it needed to reach Jupiter without burning vast amounts of fuel. It's a brilliant example of how we use nature to our advantage in space exploration. Instead of relying on brute force, we let gravity itself carry part of the load. You might say Earth gave Juno one last push, like a parent helping a child on a bicycle before it sped off alone into the deep. From that moment, Juno was committed. For nearly 3 more years, it coasted silently across the solar system, its destination growing larger and more menacing with each passing day. Jupiter, the king of planets. Juno's arrival at Jupiter on July 4th, 2016 was one of the most critical and dangerous moments of the entire mission. To enter orbit, it had to fire its main engine for just the right amount of time. Too long, and it might crash into Jupiter. Too short, and it could fly past, forever lost in interplanetary space. Thankfully, the maneuver succeeded and Juno was captured into a polar orbit around Jupiter. Unlike an equatorial orbit, which circles around the planet's middle, a polar orbit takes Juno from pole to pole. This path allows it to pass over Jupiter's entire surface while avoiding some, but not all, of the planet's most dangerous radiation zones. At first, Juno completed long 53-day orbits, gradually adjusting until it reached a tighter 14-day cycle. At its closest approach, the spacecraft came within just 4,300 kilometres of Jupiter's cloud tops. To put that into perspective, that's closer than many Earth-to-satellite distances, yet Jupiter is more than 10 times Earth's size. But this proximity comes at a cost. Jupiter is surrounded by an enormous radiation belt, far more intense than Earth's Van Allen belts. The charged particles trapped there can fry electronics within minutes. For Juno, passing through these regions was unavoidable. So how do you protect delicate scientific instruments against such an onslaught? NASA designed Juno with a titanium vault about 1 centimetre thick, enclosing its most vital systems. This shielding reduces radiation damage, but it cannot stop it entirely. Over time, Jupiter's relentless radiation will wear Juno down, limiting the spacecraft's lifespan to about 20 months in orbit. Some instruments were never expected to survive longer than the first 8 or 9 months. In a sense, Juno is like a soldier charging into battle, armoured but not invincible. Every orbit is a test of endurance. Every close pass is a gamble with one of the most hostile environments in the solar system. So what exactly is Juno doing at Jupiter? Unlike the Galileo probe before it, Juno is not focusing on the planet's many fascinating moons. Instead, it is dedicated entirely to Jupiter itself. One of its primary goals is to measure the amount of water in Jupiter's atmosphere. This may sound simple, but it has profound implications. The quantity of water can help scientists decide between competing theories about how Jupiter, and by extension the solar system, formed. Did Jupiter form quickly, sweeping up icy material from the outer disk? Or did it grow more slowly, pulling in gas and dust over time? Water holds part of the answer. Juno also peers deep into the planet's atmosphere, measuring its composition, temperature, and cloud motions. By doing so, it helps us understand the hidden processes driving those iconic belts and storms we see through telescopes. Another major task is mapping Jupiter's magnetic and gravity fields. The magnetic field is particularly fascinating. Jupiter's magnetosphere is the largest structure in the solar system. If it were visible in the night sky from Earth, it would appear larger than the full moon, stretching across vast distances. By flying over the poles, Juno gets an unprecedented view of how this magnetic field behaves and how it interacts with Jupiter's atmosphere. It studies the auroras, the northern and southern lights of Jupiter, which are far more powerful than anything on Earth. These glowing displays reveal how charged particles from the Sun and Jupiter's own environment funnel into the atmosphere along magnetic field lines. Ultimately, Juno's mission is not just about Jupiter. By learning how this giant planet formed and evolved, we gain insight into the history of our own world. After all, the conditions around Jupiter in the early solar system may have influenced Earth's development, including the ingredients for life. Every orbit, every measurement is a step closer to understanding not only Jupiter, but the story of how planets, including our own, come to be. You might be curious, why is this spacecraft called Juno? The name comes from Greco-Roman mythology. According to legend, the god Jupiter drew a veil of clouds around himself to conceal his mischief from others. But his wife, the goddess Juno, was able to see through the veil and uncover his true nature. The metaphor is a perfect fit. Just as the mythological Juno pierced through Jupiter's disguise, NASA's Juno is designed to see beneath the thick clouds of the planet, revealing its hidden secrets. It is a reminder that even in science, we often use stories and symbols to give our missions deeper meaning. This small detail connects the spacecraft to a tradition that spans thousands of years, humanity's attempt to make sense of the heavens, whether through myth or through science. Juno's mission is one of courage, innovation, and discovery. It represents humanity's determination to explore even when faced with staggering challenges. From its carefully planned journey across the solar system to its daring dives close to Jupiter's cloud tops, Juno is a testament to what we can achieve when science, engineering, and imagination come together. But the story is not finished. As Juno continues its orbits, it sends back data that reshapes our understanding of Jupiter. Each new image, each measurement opens another chapter in the story of the largest planet in our solar system. And with every discovery, we also learn more about ourselves, our origins, and our place in the cosmos. So, as we watch Juno circle the gas giant, let's remember this little spacecraft built on Earth carries with it some of the biggest questions we can ask. How did our solar system form? What role did Jupiter play? And could the answers hidden in the swirling depths of a distant world bring us closer to understanding the origins of life itself? Thank you for joining us on this journey. If you enjoyed exploring with us today, don't forget to subscribe so together we can keep venturing further into the cosmos.